In this video, we'll be talking about the basic algebraic derivative rules, as well as start introducing the transcendental function derivative rules. So our first derivative function is the constant, so we're going to go ahead and take d dx of the constant function, which again is always going to give us 0. In terms of an algebraic function, remember an algebraic function is any function of the form x to the power of n. That derivative function is going to be simply, again, drop the power down in front and then subtract 1 from the power. If I have a constant multiplied by any function, so if I have d dx of a constant times some function f of x, well, this is just as simple as saying that I can pull the constant out and then take the derivative of that function, which, remember, the derivative of some kind of function f of x, the notation we use for that is f prime of x. The derivative of some difference of two functions, so I have the d dx of f of x, say, plus or minus g of x. Well, remember, again, we can split the derivative over additions or subtractions. So this is the same thing as saying I have d dx of f of x plus or minus d dx of g of x, which, again, remember, using the appropriate notation, is f prime of x plus or minus f prime of, or sorry, g prime of x. Now we get into the rules that we have. Your product rule, again, your product rule is if I have the derivative of two functions multiplied together, that rule upholds to be the derivative of the first times the second left unchanged plus the derivative of the second times the first the first unchanged. Okay. Now keep in mind, notice how I immediately went from this format with d dx to the derivative format notation rules. Again, this notation is applicable. You may write d dx and then of f over here, something like that. But again, this notation gets a little bit clunky, so we stick to using that apostrophe notation. Your quotient rule, again, is very similar to that of your product rule, except for now you're going to have the derivative of f of x divided by g of x is the same thing as the derivative of the first times the second minus the derivative of the second times the first, all divided by the second squared. So I'm going to put that squared there because that notation is going to be something you have to be comfortable with. Again, this can be written this way or it can be written this way. But keep in mind that when I put the square out here or the square in here, they mean the same thing, and that's going to be something that comes up in other functions that we see more frequently. Now the derivative of composition function, this is your chain rule, which I'm going to write over here. This is your chain rule. Okay, your chain rule is the derivative of f of g of x. Remember, is we make sure I have enough parentheses there. Yes, that is going to be equal to the derivative of the outside function with the inside left unchanged times the derivative of the inside function. Okay, so there's your chain rule.